So now that we know a bit more about the layers of the earth and what's beneath our feet, let's talk about how they move. We've used a couple different words to describe the different layers, and that's because there are really two different methods that are used. There are the compositional layers, which are what are they made of? What kind of rock is it? And then there are the mechanical layers, which are how do they react to pressure? What state of matter are they? How do they flow, etc. So we've kind of used these interchangeably, and lots of time we will continue to do so, but I want to make the distinction now. The compositional layers are just crust, mantle, core. The most simple, there are three different types of rock, essentially. The mechanical layers gets a little more detailed. There are five mechanical layers. The lithosphere is the crust and a tiny bit of the mantle, but essentially just the crust. This is where the tectonic plates that we'll learn more about next week live. The top part of the mantle is the asthenosphere. This is just the upper mantle. It is sometimes called the plastic mantle because this is solid, but it can flow kind of like a liquid, and we'll get back to that in a second. Then the rest of the mantle, the stiffer mantle, is called the mesosphere. We'll mostly just refer to that as the mantle in my class. Then there's the outer core, which is liquid, and the inner core, which is solid. It is hot enough in the center of the earth that the outer core melts and it is liquid iron and nickel. But the deeper you go, the higher the pressure is, and all the way at the center, at the inner core, pressure outweighs temperature, and it is compressed into a solid in the inner core. So let me go back to the asthenosphere. I said that this is solid, but it can move like a liquid. It can flow like a liquid. This is something called a non-Newtonian fluid. So let's see a little bit what that looks like.
Right now we're mixing in the cornstarch and the water, and we're creating this still thing called a non-Newtonian fluid. When it comes under pressure, you push on it, you jump on it, you walk on it, it behaves like a solid. You can take a hammer, hit it, and it'll bounce back. However, if you just sit on it, it's sinking, and it's kind of hard to get out. That good is just water and cornstarch. Nothing, some food coloring, we're adding it a little bit to make it look nicer, more appealing. This today has been the funnest part. Again, a lot of people were hesitant about it at first, and some probably still are.
So they're playing around with what we would call oobleck. It is a mix of cornstarch and water, and is really, really easy to make at home. It looks and flows like a liquid, but if you apply pressure to it, it acts like a solid. So I can scoop a little bit of my oobleck up, and when I dig my pencil in, it gets stuck like a solid. But the minute there isn't so much pressure applying, it's more like a liquid and it can flow really easily. This is kind of what the upper mantle or the asthenosphere is like. It is solid. You couldn't just punch your way through it, but it can still flow. It can still move. And that flow is really important because that allows convection currents to happen. We're going to do a whole lab about convection currents, but you've seen these in your life, even if you haven't thought about it before. This happens in the atmosphere, in the air, in a classroom, in the ocean, and deep within earth, and in a pot of boiling water on your stove. Warm things rise and cold things sink. That makes a sphere, a cell, a current that keeps repeating. As warm things rise, they cool off and sink, and then they warm back up. All of this is powered by the intense heat at the center of the earth. Remember, the deeper you go, the hotter it gets. So it is really hot at the center of the earth. So these convection currents in the earth are what move the tectonic plates. Like I said, we'll talk about how tectonic plates move and what it causes on the surface next week. But these convection currents are what drive tectonic motion. They pull the lithosphere, which is where the plates are, apart or push it together. There are a couple of different ideas about how the convection currents in the asthenosphere maybe behave. It could be that there are multiple layers, some in the asthenosphere and some deeper in the mantle. It could be that there are these huge looping convection cells throughout the entire mantle. And it could be that they are a little bit more complicated and not nice, pretty circles of convection. There are just different ideas about how it moves, but today we're going to be working on a lab where you will see how do convection currents work and what does that look like for the center of our Earth.